Hello everyone. So David has talked about the backend and stuff, performancing. I will be going to the front-end side mostly for this talk. How many of you have done front-end or love doing front-end? It's a really tricky question to ask C# people, right? Yeah. All right. Don't worry. This is not a boring talk. I'm not talking about any particular framework or whatever. This is like a generic talk about how to spot problems in your front-end application and how we can solve them. So when we talk about the performance tuning, most of the people think that this is like a very straightforward procedure, right? It's like how they taught us to do drawing in the school. Like we start from basic shapes, and we add more stuff, we add more detail as we go, and then we reach to a point where we have a fully fledged web app, right? But we all know that that's not the case. It might go oddly wrong. Now, don't assume this is bad. This is drawing of a 7-year-old girl who draw her mother selling snow shovel at a Home Depot. Right? So things can go wrong, but we need to be careful. My name is Yaser. I'm a senior consultant at Redify. I do a lot of stuff in front-end space, but also involved in back-end, so that's why I'm here today. Hopefully this talk will help you to spot some of the performance issues that you might face in any, front-end app. Before we start, let's see why we should care about the performance of the application, right? So, anyone want to guess what that number is? Any guess?
Apps. jQuery downloads per day.
Nice one. This is number of people in the world using their mobile only for browsing. Like, they actually don't use any desktop. This is number of people who only use their mobile device for whatever they're doing. Online shopping, browsing, everything, right? That's a big number. In China, 83% of people use their mobile devices for anything, right? They actually don't have any laptop or desktop. In Australia, although people have desktop or laptops or anything else, they actually have started to move towards using their mobile devices. So we have 76% of all the Australians, as of now, that are using mobile devices to browse internet, right? And we are not talking about just shopping websites. We talk about like everything. Even if you get Twitter about a performance, put a CFP up, you just go into your mobile and check it out, right? You don't really go into open up your laptop to do stuff. Some statistics done by DoubleClick shows that if your website loads before less than 5 seconds, you have a good chance of 57% bounce rate for your users, right? Lower bounce rate. Means that if it's taking more than 5 seconds, then you will lose probably about more than 57% of your users during the time. On a different research, KISSmetrics have done some research, and they found out that for shopping websites, there are 79% of the users who won't come back if they face any kind of performance issue. So if it's loading slow, if they can't click on a button, if they can't go through browsing their shopping cart or any kind of performance issue, 79% don't come back to that website ever, right? That's a lot of money. You might try different techniques like giving 99% discount or something like that, but it's not going to work. They won't come back, right? Again, on a different research, KISSmetrics did it. Every second delay on a major, let's say, commercial website or web app, it costs like 7% reduction in conversion rate. You might think that that's not a big deal, but for something like Amazon, it's like 3 million per day, right? So if they have 1 second delay on their web app, they're going to lose 3 million per day, right? So that's a lot of money. Also, it's not just about losing customers. It's more about the marketing and advertisement as well. Google in 2016 announced that they're trying to leverage the mobile speed, the page speed index on a mobile device to rank the website in the search engine, right? And they've done it in July. So from July, if your website isn't performing on a mobile device, it's going to rank lower on the search engines, right? This is a huge drawback on websites that don't perform good on a mobile device. Now, we all know why we should care now. We have some stats and where we should start. Normally, what you do is you have to choose some metrics. There are many metrics out there that you can choose from. I'll just list some of the most important ones. First meaningful paint is where the very first thing that user sees on a page. Anything, like a banner, a footer, some images. If you think of Twitter, let's say you have like the first tweet and then the rest comes later. Anything that comes into the first glance of the user sees, that will be on the first meaning pane. Hero rendering times. This is my favorite. Every website has different hero items on the page. Some of them, like let's say news advertisement, they have titles. Some might have images. Some might have, like, let's say Twitter would have the first tweet. Anything that would be very important for the user to see in the first glance, that would be the hero item. So the time that your hero items appears on the page is this metric. If you want to have more information, you can just follow that link. Time to be interactive. So this is when the user can actually interact with the website. So this is like after everything is loaded, and they can click on a button, they can get some responses when they deal with the website. Input responsiveness. This is where, for example, if you have a couple of inputs on the page, whether they are buttons or whether they are text inputs or anything else, this is the time that takes until they interact with the input until they get a response back. So if they're typing on something, if you have a, let's say, type ahead or autocomplete or something like that, by the time they're typing until they get a result back, that's the difference that comes into this metric. And the last one is perceptual speed index. This is between the time that you have the first meaningful thing until it gets interactive, right? These are kind of hard to imagine in a text-only format, so this is how it looks like, right? So first paint, you'll see on the left side, we have many different metrics. I'll just use some of those. The speed index is between the first paint and time to interactive, fully loaded, where everything is ready, and stuff like that. So this is sort of you'll know from these metrics which one is more important for you. They're not applicable for everything, right? You might have different purposes on your website. You have to choose the metrics wisely, otherwise you'll spend a lot of money and time on the wrong spot. The very important thing that you should do in the beginning of your process is gathering information. And there are two sources of information you can get from. The first one is field data. This is actual production server. So whatever you have, you can use the performance tools like New Relic or anything else to gather performance information about your website. How much it's going to take them to click on something to get a response from the page back, how much it's going to take for a page to load and stuff like that. You get it from the production server. Once you have that, you can actually come and gather some data in the lab environment where your developers are developing on your environment that is internal for your only internal users only. Now the mix of these two are a great source of information to start tuning the performance in general. Now the process starts by gathering some information from field data, and then you come back, you revise something, you do a change, and then you roll it back, you deploy to production, and you watch what happens. And the most important thing is that you have to do it one at a time. If you apply a couple of changes and something goes wrong, you don't know what was wrong, right? So you do one at a time, you do one metric, gather the data, fix that issue, and then roll it to production, watch what happens. If it has a positive impact, so far, if it's got a negative effect, you can roll back and apply a different change. You have to know your tools when we talk about the web performance, right? The very first category of tools are passive monitoring tools. These are like Lighthouse, which is now integrated into the Chrome DevTools. Web page test, which is a third-party application that you can use. They're sort of test your application from 3 different parts of the world, like different countries, and let you know how your app is performing during all of those interactions. And Yahoo ISO, which is like an older tool, but it's still very useful. And you have active monitoring tools, which are very good for gathering information in your live environment or your production environment, which is SpeedCare and NewRelic, right? These are, and there are many, many other tools. I just gathered like a couple of very well-known and most used tools that the front-end developers will use. Now, Lighthouse, which is now in the Chrome DevTools, is sort of a very good tool to start with when you're trying to measure performance of a website. It gives you a lot of different metrics in different categories. So they have 5 categories: the performance, progressive web applications, accessibility, best practices, and SEO. These are not necessarily indicating that your website is performing poor or you have problems, but this is a really great start if you want to see what are the best places that you can start improving your performance. We will see a demo of this shortly after. And then the web page test also is a very good start. You can sort of have your URL, put it in the web page test, and it gives you a very detailed chart of how your app is progressing by each millisecond that goes on until it gets loaded and also the interactions happen. So let's do a demo. If you're interested in taking up in a sort of activity to get rid of this sort of after dinner state, head to this URL. I've created a little app that you can use. You can pair up with them because you can't probably measure it on your mobile while you're browsing. So we have 3 websites we are tackling tonight. There is Spotify, PayPal, and DDD. Either DDD, Melbourne, Perth, Sydney, it doesn't matter. So you can start browsing the website, have a look at how many seconds does it take, and in the app that I created, there are 3 text boxes that you can put number of seconds that it took for that app to load. And then once you click submit, you will get an overview of average time that it takes, and I'll do that here as well. While you're doing that, we'll have a look at the performance review of a website. Let me just connect to my hotspot. That's not my laptop. Okay. Do we have any candidate for the website we want to try? Let's do Amazon. All right. So we'll start with the wrong place. There's DevTools. All right. So we go to Audit tab. Now you can see we can tackle all of those, but we don't care about really those stuff, so we just do the performance. You can try different simulating features like simulated 3G or applied 3G or no throttling at all. We'll just deal with the first one, and then you can clear the storage, which means that this is simulating the first user that enters this website. Now let's see how it performs. While that's happening, let's bring this up, see how we're doing. How many people have entered something in here? Right, so I'll just put 0 for now. Right. We don't have anything for Spotify yet. PayPal. Easy Perth. Alright, so let's have a look at what's happening. So first, meaningful paint, not too bad, about 3.5 seconds. It's still bad for a commercial website, but let's move on. First, meaningful paint is about 4.7, and that's a lot. That's a lot of time for the first user to see the website. Time to interaction is about 10 seconds. That's like...
Is that a dot or a comma?
Sorry? That's comma, but that's milliseconds, so this will be around 9.3 seconds. And then estimated input latency is like 110 milliseconds, which is not that bad. But in here, in this section, you can sort of see during the time how the site is rendering. So you can see that the first meaningful frame is about 3.3 seconds, which is here, and then goes to add more content. So from 0 to here, you don't see anything, right? That's a white space, white screen for a lot of users on a mobile device. Now that's using throttling, but that's not always the case. People might have a good mobile device, but they might have a bad network, right? So all of those contribute to that. Now, on the section below, you sort of see a lot of metrics that are very helpful. Like, you see where is your most important item to tackle. The first one is properly sized images. So they're using like the wrong dimensions on the website on a mobile device. If they have a, I don't know, image with a big resolution, they don't have a smaller version for a mobile device. So that image is transferred into the mobile device. So you can start see like which images can be optimized. And we'll go through the techniques that you can do as well. So images, again, next-gen format. This is like serving images in WebP format or JPEG 2000, which are the newer formats. And down below, you see some diagnostics. And the very first one is the main thread work. This is the main thread that JavaScript runs in your browser. This is the one that takes the most time for your website to load. And you can sort of see a breakdown of how much time each one of these items is taking, and you can sort of go and tackle all of those. Now, I won't go too detailed into this tool. This is a really great tool that you can use to tackle all of those. You can also sort of go to this view trace, which gives you a nice overview of how stuff are happening. You can zoom in here by, I think this is disabled here, but that's okay. So you can sort of see what was happening at that time. The yellow, the orangey color is the thread, the JavaScript thread. You have styles, you have fonts, everything that is appearing on each stage you can sort of see in this level. You can zoom in to any more details in here, but this is a very good start for your performance tuning. Let's go back here. All right, so what next? Now we know what areas we have to tackle. What should we do next? We have to set some goals before we start improving our performance, right? We have to know what are we tackling. There are some strict goals on best practices that I mentioned here, but this is not applicable for all the websites. These are for commercial big websites. You should have 100 millisecond response if you want to retain your users. That means you should have 60 frames per second rate for animations. This means that you only have 16.6 milliseconds for your code to run. The rest is handled by the browser and all this different stuff that is running your code as well. So you only have, on each frame, you only have 16 milliseconds to operate. So you should be careful if you add like a lot of animations, if you have, I don't know, if you're loading some stalls after something is loaded, or if you're manually manipulating the DOM. These are all affect these times. Speed index should be less than 1,250. That's the time between your, again to recap, between the first meaningful pane and the interactive. So that's like millisecond, right? You should have 1 second, 250 millisecond gap between the two. And also the time to interactive should be less than 5 seconds on a 3G network. And you can simulate that by going to the network tab, or as I did, going to the audit tab. Now, for the size of your app, the whole bundle, including everything, should be maximum 107K gzip, right? And that transforms to 0.8 to 1 megabyte decompressed. So this is like decompressed after it's transformed to the browser. Now we have compression enabled in the server side that gets transformed, but you have only 170K if you want to reach those goals, right? Now when I saw this number, I was like, that's a lot. And the reason is we have average size of 3 megabyte in 2018, right? In July 2018, they did a research, and the average size of the websites are 3 megabyte. Now, this is compressed. So compress that much, and then you have to have like 170K. So imagine how much you should do to reduce this stuff. We'll go through some of the techniques, but these are a bit extreme. You don't need to have that. You don't need to match those goals if you don't care about losing, I don't know, 3 million per day. But if you do, then you're gonna.
So this is for web, for mobile, not.
This is for mobile. Yeah.
Yeah.
I was just wondering if you know, are there any stats about what's actually taking up most of that space?
We'll go through that later.
Oh, okay.
The most expensive one is JavaScript.
What a surprise. Yeah.
Yeah, so after seeing those stats, you might be in this state, which is fine. We'll get through this. This is a temporary state. Now, before we go deep into how we can deal with the performance, let's see how browsers work. So when the request comes from a page, there are two main threads that are happening on receiving the information. There's the HTML and there's the CSS. So from the HTML, you have the HTML DOM, and then you have the CSS DOM for the CSS. Now, this is happening as you're going through the time. These will get merged into a render tree, which is including everything, HTML and CSS. Still no paint. Then it goes to a layout, so the boxing model, how the pages layout, what you have, a footer, header, section, the margins, paddings, everything. And then it goes to a paint state. So at the end, you will see everything merged into this. Now, this is very important because when you're tackling all those criteria, you have to know how this works so that you can tackle it in the right time and space throughout the code base. Now that we know that, the critical rendering path, which is a measure that we should really care about, is when we talk about perceived performance in terms of how the user sees your website performance. Now, if you care about the mobile, the user doesn't really care about what happens during the initial, entering the URL in the address bar until the page is loaded. They care about what they see as they get there, right? So if you really care about the critical rendering path, you can start rendering stuff as they come, slowly and then steadily until you get to the end. You don't need to wait for everything until they finish. So that has a lot of thought behind it. You have to apply a lot of techniques, but this is how you let the user think that the site is faster, where it's not really different from the state before you applied these techniques. It's just that how they perceive the performance of your web app. Now, simple rules for this to work is that you have to stream HTML to the client. Now, many of us don't do this. We just use the normal out-of-the-box features of any backend we use, whether it's Node, whether it's ASP.NET Core, or anything else. But you can enable streaming so that the browser can parse stuff as they come. They don't need to wait for the whole thing, and Google does it. If you go into the Chrome network tab and enter the main Google website address, they send you the response, but they also send you the initial header for the result page, but you haven't typed anything. But they're sending stuff before you even requested it, right? Once you type stuff and hit enter, then they do the search and send the result, which is the list and stuff that is coming back. But the browser already knows that it has to start parsing the string that is coming until you get the whole response. And that's how you sort of think that it's really fast, whereas no, it's like the same mechanism, but it's sending stuff in chunks. And then get the CSS to client fast. However you can. If you use a CDN, if you reduce the number of styles that you have, however you can, just get the CSS to a minimum, because until the CSS DOM is rendered, nothing goes into the screen, right? The paint state is where we care about. Now, HTML and CSS, fine. Did we miss anything? Yeah, a lot. Our friend JavaScript, which is the most expensive assets that gets delivered to client. Images, a large chunks of data that is taken for loading a website or images, right? And you can see it everywhere. And there are not really many techniques that are applied to images when you talk about loading those. Web fonts, very popular. Like, I've seen websites use like 10 different web fonts in 10 different places. They don't really know that all of these resources are taking network bandwidth and time to render all of those. And some external resources. Let's say you have ads from somewhere else, Google Analytics, stuff like that, right? So let's be a bit more quicker. JavaScript, you would have 3 different categories: external, which require a network request to request it and get it; internal, which is bundled in as part of your HTML page, which then gets delivered with your HTML; and then you have inline, which is sort of similar to the internal, but don't use this one. This is where, for example, you say on click or like unload and do stuff like that. Now you should prevent all of those, because those are the most expensive ones. They require them to be re-rendered a couple of times before it gets to the end user. There is a really strong reason why we shouldn't manipulate the DOM using JavaScript. And that means that because browser doesn't know what's inside your code, it has to wait until all of the code is finished. It doesn't know whether you're adding a child node, or you're changing a parent node, or you're actually adding some nodes to the DOM. It has to wait until it's finished. Also, don't change the CSS using JavaScript. That has the same effect. The browser has to wait for all of these to be applied before it can render anything. Now that we know all of these basics, let's start doing some performance improvements. The first thing, before we go too deep, is the purple pattern. Now, the purple pattern was introduced by Google in 2016. It stands for push, which is you push stuff from server to client before it's requested, which is known as HTTP to server push. You have render, which is you render your client side on the server, at least the main route, and then you send it as a rendered object to the browser. So the only thing the browser has to do is just parse that, right? So it's already rendered, which is really fast. But it means that your initial request time should be.
What do you mean by rendered?
So let's say you have a client app which is using a framework, let's say React or Angular, right? You can sort of say that I want this particular route, which is probably your home page or the page that most of the users use. They actually have like server-side rendering techniques that you can render all of that into a rendered HTML. It's like adding, I don't know, SEO ability to your spa, right? To your single-page application. It means that when the search engine requests that particular route of your website, it actually gets the whole rendered content. It doesn't need to wait for done in the server side. All you get is a rendered HTML that just gets shown in the browser, which is very fast. You have Precache, which is when you start requesting the stuff before they are needed. So let's say you have a web font, or you have a external style sheet. If you're rendering your main page and you know that, for example, the most of the people go into the shop page, you can start pre-caching resources that are needed to render the shop page beforehand. So you send the request comes back from the server, but it is cached in the browser. But the only thing that you need to be careful is that don't overuse this feature, because it's going to add a lot of latency, and it's also consuming a lot of data, which is very painful for people who pay like money for every gigabyte or something like that on a data plan. And lazy load stuff. So when we talk about any framework that you use, or even if you don't use any framework, you're using vanilla JS, you can always break your application into multiple logical sub apps or smaller apps, and then lazy load them. So they don't need to be bundled in your main bundle and sent to the client. They can be bundled separately. So let's say you have your home page and you have a shop and you have an about me, and you know that, for example, people don't usually go to the about page, so you can lazy load that one. So by the time they hit the route, then there is a request and the response comes back and they can see that. So they can wait when they go into that page, not when the main page is rendered. If you want to know more about it, head to the Google developer website. There are tons of goodies in there about all of these techniques and details on how you actually get there. For the styles, there are two techniques that you can use for the Linkrel Preload, which is you're preloading the style before it's required, which is happening for the same page. So let's say you have a couple of different styles. You can put the different style tags, break that style sheet into multiple style sheets, smaller style sheets, and then you can put different link tags for all of those, even in the body. It doesn't need to be in the head. You can put the style sheets in the body as you go, and the browser requests that, and then that's how the browser renders stuff gradually while it's going to the end of the page, right? And then you can have your initial CSS, which is required for rendering the web, in line with your main HTML, which transfers with your HTML and doesn't require an extra network request. An example of the preload is like that. Currently, as of now, browsers don't support automatic changing of the rel, so you have to do this bit manually, which is, you mentioned that after it's loaded, this resource is loaded, you just change the rel to the slashy. Otherwise, the browser doesn't know that this has to be integrated with your CSS DOM. And you have to have a no script tag for when the user disables the JavaScript on a client, because you don't want to lose your styles when the JavaScript is disabled. If you use a bundler like Webpack or any other framework, they usually have plugins for it. This is a Webpack plugin which lets you do that for all of the styles in your site, and it does it automatically. You don't need to worry about any of those. In terms of JavaScript, there are two basic techniques that many people don't know about. Now, you have defer on your script tag, which is sending the request for the JavaScript, but it doesn't block rendering of the page by the browser. So the browser is doing stuff, there's a request, goes to the server, gets the JavaScript back. By the time the browser has rendered all of the DOM, it's reaching to the end, there's nothing else, then it applies the JavaScript afterwards. That really makes your application fast. This is where we can start improving a lot. And there's async, which is sort of similar to defer, but the difference is when you use async, the browser sends the request, starts parsing the DOM, but it pauses the DOM as soon as the request comes back. So defer was, it don't care about the request, just parse everything and then execute at the end. Async is execute at the point of response comes back into the browser.
Question. You said before that if the script alters the DOM, you said don't do that. Yeah. Right. And it's bound to do it. So when you're delaying. When you use these two words on the script tag, the browser really doesn't care what have you done in your script. It just sends a request, starts parsing the DOM. When the JavaScript is back, if you are doing something with the DOM, it reruns the DOM for you. So it's really like delaying that sort of manual manipulation until the request comes back from the server. And then make sure that all of the script tags are right at the bottom. That
That means that the browser has to go through all of the main elements on the page. They get rendered, and then the JavaScript is run at the end. So you don't block any of those gradually showing content that you have on your page. And just less JavaScript if you can. That's not a bad idea. Like a lot of us just go and start adding JavaScript wherever we can, but we don't really think about how that affects the performance of the web application. Now, there are a lot of different techniques that we briefly talked through. The code splitting, which means that you have different bundles for different routes, and then you lazy load them. There are techniques like again, plugins for it. For the Webpack, you can find different plugins for different bundlers as well. You can have dynamic imports with ES6 and TypeScript support. So instead of having, let's say, if you have a JavaScript which has, I don't know, 2 blocks of code which they're not really relevant to each other, you can break it into 2 different files and then import them as you go inside the code. So you can import a JavaScript file inside your JavaScript, which means that that file isn't loaded until it's needed, right? So you're deferring part of the JavaScript to be loaded later on using the dynamic import. And analyze your bundle. There are many bundle analyzers like this one, which is for Webpack, which visually tell you how your bundle is structured, like how much space each of your elements are getting, how much style do you have, how much JavaScript do you have, how much font do you have, images and stuff like that. If you use web fonts, they can be cached, so just use the cached version of the browser if you can. Don't just try to overload those fonts every time that the page is refreshed or you go to a different navigation. Use prefetch and preload like the styles that we did. This can be applied for the web fonts as well. And think about whether you actually need it or not. Most of the cases, because we have a style guide and they use a web font, we actually go and import a web font. But we can sort of go and have a look at the existing system fonts and find something that is similar and avoid using that, right? And there's nothing wrong with that. And if you really need to do it, have a look at the eBay's font strategy. They spent 2 years investigating how they can improve the web fonts load. So there are heaps of stuff in their guidelines. For the images, mainly they get like more than 50% of the capacity of the website. Like anything that you send to the client, more than 50% of it is images. Now, when we talk about the images, you're going to make sure that you use the right dimensions for the right, let's say, the right media query or your screen size that you have between different devices. If you have a mobile version, you don't need to send I don't know, 1200 or something like that resolution. If you have a smaller device, you can use a smaller image. And there are techniques that I'll look through that you can use that to actually specify different images for different sizes, and the browser is smart enough to load those per device. You can use next-gen formats, which are like WebP, JPEG 2000. These are completely different algorithms that are not supported by all the major browsers, but mix of them will get you to a fairly reasonable space. And you can have the image compression as part of your build process. So no matter what images are going in there, there's always a compression algorithm applied on top of the images applied to your build. It means that you have applied at least some level of compression to your images. And just lazy load them like the one you see before, the preload and precache also apply to the images as well. And less of images if you can. It doesn't need to be image everywhere. You can just sort of deliver the same thing with SVGs, with different formats. Now, I did this with DDD Perth website. I talked to Rob Moore, who's managing this website, and who's a colleague of mine in Perth. And I did an initial performance test on the website. It was 33, as you can see on the performance. I did a couple of small techniques and have a look at what difference it made. First of all, I made sure that I used progressive images. Progressive images are using the techniques for streaming images back to the client. It means that the client start gradually see something until it gets to the end state. They don't need to wait for the whole thing to load. And also use the source set, which is being there, but no one is really, like a lot of people don't know about this. You can have different dimension images for different like width, and then you can have like source settings for different formats. Like I'm using WebP for some of the browsers that support that. Otherwise, they use the JPEG version, and they are breakdown into different sizes. And there's a fallback, which is like the smaller one, which I use. And I applied these techniques to all of the images on the DDD Perth website. And from that, it came up to 60%. Now that's a static website, but you can see that sort of same technique applied to a commercial website, how much impact it can have. Just to recap, so we talked about having getting some information about the field data, doing some changes, and then deploying, and then do this process again and again. Some of the techniques that you can use with all of the resources are caching. The browser has a default caching mechanism that they use, that mostly use. But if you don't set the right headers from the server side, they actually don't utilize it. So you're going to be careful when you're sending a resource. If it doesn't change that much, you can set a 1 month period of caching. So the browser caches that for 1 month. So whenever that resource is requested, it gets served from the cache of the browser instead of from the server again. But if you have something like more dynamic, you can increase the caching period. And you can use the different techniques like server-side caching, which is you actually cache some stuff on the server, and when they get requested, you don't need to process those. This is mainly good for dynamic information. Let's say you have a query which is used a lot of time, and you know that that's not going to take a lot of memory on the server. You can actually cache those resources and send them back without even hitting your DB or stuff like that. Again, browser caching, which is supported by all the major browsers and also mobile devices that you can use. And you can also use CDN, which is very good when you have like a multi-international website and people hit your website from different continents or different countries. If you have leveraged a CDN, we'll make sure that the resource gets to a client from the nearest center, and it's very faster than if you have like one server and you're serving that the resources from there. These are some of the references that I mentioned during the talk. There are good checklists that you can sort of find in the first link. Google's developers, there's a blog post called Perf Matters, that there's heaps of good stuff in there that you can leverage and start improving your performance web apps. High performing web fonts, which is iterating through a couple of different strategies to load web fonts more efficient, and also image optimization, which is a really broad topic. I couldn't cover a lot of stuff in here, but there are tons of stuff that you can do in regard to your images. And any questions? No?
Well, are you hoping the promise of WebAssembly will ease the burden of all the JavaScript loading?
WebAssembly is a really interesting space, but it can be really used like the way we use JavaScript. If you start overusing, I see like tweets, people, I don't know, load Windows on a browser, and I was like, whoa, I don't know if that's a good idea or not. Like, it can go wrong in the same way that JavaScript has gone wrong.
But it's tiny compared to transmitting.
Depends what you, it depends like what you load in it. The WebAssembly itself just gives you a platform that you can load stuff into the browser that doesn't necessarily require compiling, and they leverage the machine language for displaying stuff on the browser. All right, you can find me on Twitter. I mainly tweet about front-end stuff, occasionally about back-end stuff, because I go into different gigs and try different stuff. And hope you guys enjoyed this and are just a bit more interesting from the first question I asked, to not just at least do some research and stuff. You don't need to. If you have a pet project, that's a great start. You can always start learning stuff in the performance space, and hope you enjoyed this one.